Good day, everyone. The Jamb Master is live. The Jamb Master is live. Jamb Master chemistry class. If you're active, say active. If you are active, say active. The Jamb Master is live. Jamb Master chemistry class. We are not wasting time today. We don't need to motivate anybody. It's 52 days to Jamb. It is 52 days to Jamb. So I'm not going to motivate anybody today. I'm just going to teach. No time to motivate or ginger you. If you're not gingered and you have 52 days more to Jamb, then you're not ready. If you're not gingered and you have just 52 days to Jamb, then you're not ready. So you're welcome to the Jamb Master class. Settle down, get your writing material off your TikTok, off your Facebook, off all your social media. I'm not here to motivate you. I'm here to make you pass your Jamb. No time for too much talk today. No time for too much talk today. Get writing materials. Get rid of all distractions. Let us start. You can see on the board here, this is a continuation of last week's class on chemistry. This is exact continuation of last week's class on chemistry. For those just joining us, I posted the link. Of last week's class on our group. I already posted it earlier in the day, right? The link of last week's chemistry class so that you can flow along with today's class. I hope you have watched last week's video. In case you're here and you have not watched last week's video, message me. I can still send the video to you so that you can flow in this class very well. If you've not watched last week's video, you might be lost in today's class because today's class is a continuation of last week's class. Today's class is a continuation of last week's class. This is my WhatsApp number. Message me, sir, please, I want to join your class. Sir, please, how does your class work? All our classes are recorded, so any class you miss, I can send them to you if you have registered with us. So message me if you've not gotten the link for last week's class. As you can see here, I'm starting with an assignment solution because at the end of last week's class, I gave an assignment and I want to solve the assignment, then forge ahead. Please get your writing materials and get focused. Don't wait for anybody to motivate you. I may not be coming too often to come and be checking whether you are serious or not. If you like, go. Your time is time counting. 52 days to Jamb. There is no longer time to waste. If you cannot motivate yourself by now, if you find yourself leaving you have joined the life now, after a few minutes you just leave, or you allow anything to distract you, that's your business. Now we cannot allow anybody to dull us. Serious students, pay attention. Before we start, type I will not leave till the end of this class. Before we start this class now, type I will not leave till the end of this class. Off all distractions. Inform your parents, mommy, I'm having class. So if I fail, you will blame me. Inform your daddy, daddy, I'm having class. So they say we should not leave the class. If they leave the class, they will not have me back. Tell your parents that if you leave, they will not have you back. So they should not send you any message. Tell your sister, tell your auntie, tell your friend that nobody should call you. That if you leave, they will not have you back. If you tell them like that, they will not disturb you. Tell them that if you leave this life, man, they will not have you back again. Are we together? So type on the comment section that I will not leave this class till the end. I will not leave this class till the end. I will not leave this class to the end. If you need to plug your phone to light or to power bank so that you don't have low battery, plug it now. Anything you need to do to make sure that nothing moves you from this class, do it now. Let's get started. Let us get started. As soon as I start teaching now, I'm not coming to check anybody serious or not. After that teaching, Jamb is 52 days away. Jamb is 52 days, 5-2. 52 days to Jamb, so no more time to pet anybody. No more time to pet anybody. 52 days to Jamb. And you must pass your Jamb this year. My students don't score less than 280. My students don't score less than 280. Now type ready and we'll start. Type ready and we'll get started. Okay, let's go. I will not leave this class till the end. I will not leave this class till the end. Stick to your word. Let's go now. Find the number of protons, neutrons, and electrons in the following elements. 1, we have fluorine. 2, we have boron. 3, we have magnesium. 1, we have fluorine. 2, we have boron. 3, we have magnesium. Number of proton, neutron, and electron in the following elements. Now, class, they asked us to find these three things in their charged and uncharged states. If you have watched our last week class, or if you were here last week, you would have noticed that I taught you how to find number of proton, neutron, and electron, both in their charged and uncharged state. Let us start with fluorine. Class, what number does fluorine fall on the element table? Last week, we also gave the element table. That's why I said you should have watched last week's class so you can flow with this week's class. I gave them an element table. Every good chemistry student should be able to state the first 20 elements without blinking your eyes. Every good chemistry student should be able to state the first 20 elements without blinking your eyes, without even making any mistake. So you will know where fluorine falls under in the first 20 elements. Fluorine is number 9 because it starts with hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So fluorine is number 9. And that number that the element falls under also stands for its atomic number. The number that the element falls under in the element table also stands for the atomic number. And what is atomic number? Atomic number is number of what? Protons. Atomic number is number of protons. Last week I told you that atomic number is written with symbol Z. This is the symbol for atomic number, Z. Atomic number, the symbol for atomic number is what? Z. And usually written as a subscript. What do you mean by subscript? It's written below. Atomic number is written as a subscript. Subscript means it's written what? Below. You can see 9. Below. Subscript written below. Atomic number. Now from the atomic number, you can easily get the atomic mass. I told you last week as well. That if the atomic number is odd, this is an odd number, right? To get the atomic mass, multiply the atomic number by 2 and add 1. Multiply the atomic number by 2 and add 1. 9 times 2, 18. 18 plus 1, 19. I'll come again one more time. If the atomic number of an element is odd, like for example 9 is an odd number, multiply 9 by 2, you have 18. Then add 1 to 18, you have 19. You have the atomic mass. So atomic mass is 19. And from last week I told you, atomic mass is number of proton plus neutron present in the nucleus of the atom of an element. Number of proton plus neutron present in the nucleus of the atom of an element. Number of proton plus neutron present in the nucleus of the atom of an element. Number of proton and what? Neutron. Atomic mass, number of proton and neutron. Atomic number is number of protons only. Atomic number is number of protons only. But atomic mass is number of proton plus neutron. And class, the symbol for atomic mass is A. Atomic mass is A. The symbol for atomic mass is A. And it's usually written as a superscript. So why Z is a subscript? A is a superscript. Superscripts. Why Z is a subscript? A is a superscript. What do you mean by superscripts? Superscript means written above. Superscript means written above. Why subscript means written below? Why is it important to know the atomic mass and atomic number? Without the atomic mass and atomic number, it will be difficult to answer this assignment. Assignment says we should find number of protons, neutrons, and electrons. If you don't know the atomic number and the atomic mass, you cannot answer this assignment. So that's the first thing you must do. Understand atomic number and atomic mass. And last week we told you that another name for atomic mass is mass number. Class, another name for atomic mass is mass number. Please take note. Now that we have these two parameters, we can easily get the number of protons, neutrons, and electrons. Class, this fluorine currently is not charged. This fluorine is not charged. Because elements can exist in two states. I told you last week that elements can exist in two states. And elements can either be charged or uncharged. An element can either be charged or uncharged. Elements can exist in two states. Charged or uncharged. What's the name for uncharged? Uncharged also means neutral. When an element is uncharged, it means it's what? It is neutral. Class, what does it mean for an element to be uncharged? It means it has not lost or gained any electrons. It has not lost or gained any electrons. So it is in a neutral state. Class, every element first exists in their neutral state. Every element first exists in their neutral or uncharged state. Another name for neutral is what? Uncharged. Every element first exists in their neutral or uncharged state. So what now makes elements charged? Why do elements become charged? What moves elements from uncharged to charged? Is their tendency to want to what? Gain stability. Every element wants to gain duplet or octet stability in chemistry. In chemistry, every element wants to gain duplet or octet stability. In chemistry, every element wants to gain duplet or octet stability. What's meaning of duplet or octet stability? The noble gases. The noble gases are stable in chemistry. The noble gases, also known as the rare gases or inert gases, they are very, very stable. They don't have any issues with their electron and their shells. But every other element has one issue or the other with their electrons and their shells. So in the ability to want to be like the noble gases, they either have to lose electrons or gain electrons. Elements have to lose electrons or gain electrons to be like the noble gases. But even if they lose or gain electrons, they will not exactly be like noble gases. Because noble gases are just by themselves. They don't have to acquire any charge to be themselves. But every other element that wants to copy the noble gases, they have to acquire a charge. To be like the noble gases, they have to acquire a charge. Either you acquire a positive charge or you acquire a negative charge. Every element wants to be like the noble gases. Who are noble gases in the first 20 elements? You have helium, you have neon, and you have argon. Please, I repeat again. If you have not watched our last week video, message me to send you the link. But you will not get this link if you are not a paid registered member of my class. I will not send you this link. It's locked. The video is on my channel, but you will not see it because you have not registered. You will not see it because you have not paid us. It is on my channel now, but not everybody that opens my channel can see all my videos. There are many videos on my channel that nobody can see until I grant you access. Until I grant you access. Yes. But you can ask your colleague, this class helped last week, but you will never see it on my channel. No matter how you search, you will never see it. Except I want you to see it. Except I open it up for everybody to see. Are we together? But I think I actually opened this video up. I think I put this one in public, yes. I actually opened this the video before this video. I opened it up for everybody. So everybody can actually see. If you go to my live channel, and you search for Jamb Master Live Chemistry class, I think the last week video will pop up. I think last week video will pop up. If you go to my channel and search for Jamb Master Live Chemistry class, the last week video, I made it open to everybody so you can see. But not all our videos are open to everybody. Only our registered members will have access to this class. Are we together? So in the last class, I actually explained what the noble gases functions are. Like the noble gases, for example, look at helium. Helium is number 2 on the element table. Neon is number 10 on the element table. Argon is number 18 on the element table. What is so special about helium, neon, and argon? What is so special about helium, neon, and argon? What is so special about helium, neon, and argon? Let me show you. Class, there's what we call electronic configuration. I taught last week. Electronic configuration is the arrangement of electrons in the shells of the atoms of an element. Electronic configuration is the arrangement of electrons in the shells of atoms of an element. Class, we have 4 types of shells that store electrons for elements. We have 4 types of shells that store electrons for elements. We have the K shell, the L shell, the M shell, and the N shell. We have 4 types of shells that store electrons for elements. We have the K shell, the L shell, the M shell, and the N shell. And each shell has the number of electrons they can take, the maximum capacity they can store. Class, the K shell can only store 2 electrons. The L shell can store 8 maximum. M shell can store 8 maximum. N shell can store more 18 and above electrons. 18 and above electrons. So every shell has the number of electrons they can carry. So class, K can carry from 1 to 2, but 2 is the highest. L can carry from 1 to 8, but 8 is the highest. M can carry from 1 to 8, but 8 is the highest. N is 1 to 18. Now class, follow this. Even though K can carry 1 to 2, K shell will be very happy if you give him exactly 2 electrons. He will be very happy if you fill him up. All shells are happy when you fill them up to their capacity. All shells are happy when you fill them up to their capacity. But class, not all elements have the ability to fill up the shells to the capacity. Not all elements in chemistry have the ability to fill up the shells to their capacity. But the noble gases have the ability. Look at helium. Helium has just 2 electrons. And K shell needs exactly 2 electrons. So K shell is very happy with helium. K shell is very happy with helium because helium just has 2. And K shell needs 2 exactly to fill up. Neon has 10 electrons. And K shell needs 2, L shell needs 8. So K and L are very happy with neon. K shell and L shell are very, very happy with what? Neon. Because the exact electrons they need, it gives it to them. Argon has 18 electrons. 2 in the K shell, 8 in the L shell, 2 plus 8, 10, remaining 8. 8 in the M shell. So K, L, and M shell are completely filled up for argon. This is what makes noble gases special. And this is the foundation of everything that happens in chemistry. Plus, are you aware that the reason why elements bond is because of this same reason? Some elements say, let us bond together. Me, I need 1 electron. Me, I need to give out 1 electron. You need to give me 1 electron. Let us bond together. And we'll form electrovalent bonding. Or let us share. Let's form covalent bonding. Okay, let us share a lone pair of electrons. We'll form coordinate covalent bonding. Also known as dative bonding. Every reason why elements bond, every reason why we are studying chemistry, started from this foundation. If you don't understand this foundation, you will struggle in every topic in chemistry. Have you ever noticed that you will never see all these elements, noble gases, you will never see them bonding? Plus, if an element is stable and filled up, they don't need to bond with anybody. Have you ever heard of helium chloride before? You're a chemistry student, you've been doing chemistry for SS1, SS2, SS3. Have you ever heard of neon chloride or argon hydroxide? These guys don't bond with anybody because they are stable. These guys don't pair with anybody because they are stable. The reason why elements are bonding every day is because they want to attain stability like these guys. The reason why elements are bonding every day is that they want to attain stability like these guys. And in order to attain stability, they need another element. Let me show you something quickly. The reason why sodium and chlorine are bonding together is because sodium is number 11 on the element table. Chlorine is number 17 on the element table. Plus, the electronic configuration for sodium is 281. Plus, I told you last week, the elements first start storing the electrons first in the K shell. When elements want to store electrons, they start from the K shell. When K is filled up, they move to L shell. When L is filled up, they move to M shell. And when M is filled up, they now move to N shell. So this is the sequence of how elements store electrons in their shells. They start from K, then they move to L, then they move to M, then they go to N. So class, elements don't start filling electrons from M. No, you start with K. What rule in chemistry are we following? There's a rule in chemistry that we are following. That's why we're starting with K shell first. Are you aware that K shell, L shell, M shell, and N shell, they have different energy levels? These four shells here have different energy levels. I don't want to be too fast. Let me slow down a bit. Let me slow down a bit. But there are just 52 days to Jamb. 52 days to Jamb. So I'm no more playing with you. Class, we have entered serious mode now. We have entered serious mode now. I'm no longer joking with anybody here. Follow me carefully. Let me slow down so nobody will miss out. But class, take note. In case I'm too fast, one good thing about online class is that you can rewind and watch again. And when you rewind, you will still catch up on anything you missed in front. Class, it's not compulsory that you must be in the same place everybody's watching now. Class, if there's a part you don't understand, in your own phone, just toggle it backward and watch again. Don't try to catch up with everybody and you don't understand anything. Watch at your own pace, learn at your own pace. After all, you are not all in one class. You are all in your different houses, right? So there's no rule that says you must be where we are now. If there's something I thought and I was too fast, just rewind it again. That's the advantage you have in online class. In an online class, you cannot say you don't understand. Why? Because anything you don't understand, just rewind and watch again. You cannot say, I don't understand. No. The power is in your hand in an online class. In an online class, you can rewind the video and watch again. In a physical class, you cannot rewind the teacher automatically. Sometimes in a physical class, you are too shy to raise up your hand and say you don't understand. So online class gives you a power. Anytime you don't understand, just take the video back and watch again. You don't still understand, take it back. You can watch it 10 times till you get it. Do you know you can reduce the playback speed? You can reduce the speed of your experience. Everybody does not need to watch at the same speed. There's a setting in YouTube there that can help you to reduce. You slow down while I'm teaching. You slow it down to what you can understand. So even if I'm talking fast, you can slow it down. You see your settings there. Go and ask someone to teach you how to understand YouTube. This is the power of online class. You can watch again and again and again. Even after this class is over this night, you can go back. There's a link to every video we do. You can go and click the link again and watch it again and again and again. You can watch a class 10 times. That's the power of online class. In a physical class, once you miss that day, you have missed that day. Your teacher cannot reproduce that day again. But online class, you can keep watching till you understand. So you have the power. So I don't want to see anybody talking to me and say, I don't understand. That means you are talking like an illiterate. Because you have the power to rewind the video and watch again. What do you mean by you don't understand when you have the power to rewind and watch again? You have the power to rewind and watch again. You have the power to go and click this video again. There's a link I will send. You will watch this video from beginning to the end again at your own pace. Even after this life is over. So you cannot say you don't understand. You cannot say, sir, you are too fast. No, because you can slow down my speed in your phone. You can slow down my speed in your phone. You can rewind the video and watch again. Please take note. I understand why I'm saying this now because some people will not know that. They just say, I don't understand. Sir, you are too fast. Sir, you are too this. No, you have the power. The time you used to say you don't understand, use it to rewind the video and watch again. You can watch it 10 times till you grab. Please take note of that. Let's continue. So like I said, every shell has the number of electrons they can store. Also, every shell has their energy level. Class, the shell with the lowest energy level is K shell. K shell has the lowest energy level. As you are going from K to L to M to N, the energy level of the shell is increasing. So from K shell to L shell to M shell to N shell, the energy level of the shell is doing what? Is increasing. So class, what rule tells us that when we are filling electrons in shells, we should start from lower energy level. What is the rule in chemistry? It's called Abbal's rule. On the board, it's a chemistry example, so they can ask you. Note it today, Abbal's rule. Abbal's rule tells us that when filling electrons in shells or orbitals, we should start filling it from lower energy level before we get to higher energy level. So if someone has 3 electrons to be filled, first start by filling the K shell. K can only take 2. The remaining one will go to L shell. So the electronic configuration for that element is 2, 1. 2 in the K shell, 1 in the L shell. If someone has 5 electrons, 2 electrons will go to the K shell, but K can only take 2. The remaining 3 will go to L shell. That will be 2, 3. So the configuration of that element will be 2, 3. Are we together? It's Abbal's rule that gives us that learn this in chemistry today. What is Abbal's rule? Abbal's rule states that when filling electrons in orbitals or shells, I'll come again. When filling electrons in orbitals or shells, we start by filling in orbitals of lower energy level before that of higher energy level. When filling electrons in orbitals or shells, when filling electrons in orbitals, later on I'll teach you what we call orbitals. I'll teach you what we call what? Orbitals. When filling electrons in orbitals or shells, these are shells, KLMN, we start by filling from lower energy level before the higher energy level. We start by filling from lower energy level before the higher energy level. Please take note. We start by filling from lower energy level before the higher energy level. So start by filling from K shell. When K shell is filled up, you go to L shell. When L shell is filled up, you go to M shell. When M shell is filled up, you now go to N shell. Okay. If you are watching this video, you have not yet subscribed to our channel. As Jamb is getting close, you will miss a lot of updates. Many students missed out last year. You are watching this video and you've checked, am I subscribed to this man's channel, this Jamb Master channel? No. How come? Hit the subscribe button now as you are watching me. Hit the subscribe button. Hit the subscribe button. Check. Are you subscribed to the channel? Check now. Are you subscribed to the channel? Because when Jamb is getting closer and closer, that's what updates I'll be dropping. If you're not on the channel, you will miss out. Hit the subscribe button below. Hit the subscribe button below now. On your top left corner, you see subscribe. Just hit it. Except you have already subscribed, you don't hit it. But if you have not subscribed, hit the subscribe button now. Check. Make sure you are subscribed to the channel. Now let's continue. So I explained Abbal's rule for you. So I tried to explain why is it that sodium and chlorine bond to form NaCl. Please follow me. Why is sodium and chlorine bonding to form NaCl? It's not because they like themselves. It's because they need each other. Why did sodium come and bond with chlorine to form NaCl? Not because they like themselves, but because they need each other. Class, sodium is 11 on the element table, like I said earlier. If you count your first 20 elements, sodium is number 11. And that number also stands for number of electrons. If someone has 11 electrons, based on how Abbal's rule I just taught you, if you have 11 electrons, 2 electrons will go to the K shell, 8 will go to the L shell, 2 plus 8 is what? 10. Remaining 1 out of 11 will now come to the M shell. But class, this M shell is not happy. M shell needs 8 electrons, but sodium is giving him only 1 electron. M shell needs 8 to be filled up, sodium is giving him 1. So M shell is not happy with sodium. Look at chlorine. Chlorine has 17 electrons because chlorine is number 17 on the element table. If you are calling your first 20 elements, the 17th element you mention is chlorine. If you are calling your first 20 elements, the 17th element you mention is chlorine. The 11th element you mention is sodium. The 11th element you mention is sodium. The 17th element you mention is chlorine. Class, if you are filling 17 electrons, you start with K shell 2, L shell 8, M shell 7. Class, the configuration for chlorine is 287. Class, M shell is not also happy with chlorine. M shell is not happy with chlorine. Why? M shell needs 8 electrons. Chlorine is giving him 7 electrons. Chlorine is giving him 7. M shell needs 8 electrons. Sodium is giving him 1 electrons. But this 2 is in the K shell, 8 is in the L shell. These 2 shells are happy, but M is not happy. The M shell of sodium is not happy. K shell 2, L shell 8. The M shell of chlorine is not also happy. What must sodium do for M shell to be happy? Sodium needs to either add 7 electrons to make it 8, or just throw away, give her this 1 electron, give her this 1. What does M shell for chlorine need to do to be happy? He either has to bring in 1 electron or give her these 7 electrons. Class, The smart thing for chlorine to do is to go and look for one electron and add up. The smart thing for sodium to do is to go and give out this one electron instead of looking for 7. Just give out this one electron. But in chemistry class, when an element gives out electron, it becomes positive. So when an element loses electron, you either give out or you lose. You become plus. But when an element gains electron, chlorine will gain 1 electron, it becomes what? Minus. Class, I said it last week, it doesn't make sense, right? How can you lose and you are plus? And how can you gain and you are minus? It doesn't make sense, right? Normally if you lose, you should be minus. And if you gain, you should be plus. But class, that's the mystery of chemistry. That's the mystery of chemistry. So in chemistry, when an element loses electron, it becomes positive. And when an element gains electron, it becomes negative. You see why chlorine and sodium are bonding? Because they are bonding because chlorine needs that 1 electron and sodium does not want. That 1 electron and sodium wants to give out, chlorine needs it to be stable. So sodium will give out 1 electron, chlorine will take in 1 electron. So sodium will lose 1 electron, chlorine will gain 1 electron. Sodium will lose 1 electron, chlorine will gain 1. Plus, the charge that sodium will carry is the number of electrons it lost. It lost 1 electron, so it's plus 1. The charge that chlorine will carry is the number of electrons it gained. It gained 1 electron, that's minus 1. Don't forget, when you lose electron, you are positive. You are positive in chemistry. And when you gain electron, you are negative in chemistry. So sodium loses 1 electron, that's why it's plus 1. Chlorine gain 1 electron, that's minus 1. Please take note. Please take note. And they form NaCl, sodium chloride. The reason for these 2 elements bonding is what I just showed you, is the foundation of chemistry. You will never see helium chloride because helium does not need to bond with anybody. Helium is very okay with himself. Neon is very okay with himself. Argon is very okay with himself. They don't bond. These guys don't bond. I'm making you to understand the nitty-gritty of chemistry, the foundation of chemistry, structure chemistry together. If you understand this foundation, every other topic will be very easy for you when you're reading. Let's keep going. You're not scoring less than 90% in Jamb chemistry. You're not scoring less than 90 in Jamb chemistry. You can go on personally and name my chemistry. You're not scoring less than 90 in Jamb chemistry. Let's go. Let us go. Now, look at all the things I've taught just from this small assignment. That's how I teach. Look at everything I've mentioned. I mentioned our bus rule. Just from this small assignment, look at how many things I've touched. Let's keep going, class. So, class, one thing you have learned now is this. So, we have sodium in uncharged state and sodium in charged state. We also have chlorine in uncharged state and chlorine in charged state. Right? This is why I told you that elements can exist in 2 states, uncharged, also known as neutral, or charged. But every element first starts with being uncharged or neutral. But class, I've just shown you why they become charged, because they want to be like the noble gases. So they either have to lose or gain electrons. So class, when they ask you to find number of proton, neutron, and electron, for elements in their uncharged state and their charged state, the 2 answers will be different. Class, look at this sodium is 11. Atomic number is 11. Atomic mass is 23. I've taught you how to do it. 11 times 2, 22 plus 1, 23. Odd number. Odd number. When the atomic number is odd, multiply by 2 and add 1. You have the atomic mass. Atomic number is written as a subscript. Atomic number, subscript. Atomic mass is written superscript up. Subscript means down, superscript means up. Atomic mass, superscript up. Plus, chlorine is 17 down and 35.5 up. Chlorine does not follow the rule. I told you last week there are 3 elements that do not follow the rule, right? Who can tell me the 3 elements that don't follow this rule? Type it in the comment section in my class last week. If you were in my class last week, type in the comment section. What are the 3 elements that don't follow the rule? What are the 3 elements that don't follow the rule? Type in the comment section now. I told you chlorine does not follow the rule of multiplying by 2 and add 1. It doesn't follow the rule of multiplying by 2 and add 1. Sodium follows the rule. Look at sodium. 11 times 2, 22. 22 plus 1, 23. But chlorine doesn't follow the rule. There are 2 more elements I told you last week that don't follow the rule. If you want to get access to last week's class, message me on WhatsApp. Now let's go. So atomic mass of sodium is 23. Atomic number is 11. Atomic mass of chlorine is 35.5. Atomic number is 17. What's number of proton, neutron, and electron for sodium? Class, proton is 11. Neutron, class, how do you get neutron? Atomic mass minus atomic number. 23 minus 11 is what? 12. an electron for this uncharged sodium is also 11. Class, when an element is uncharged, number of proton and electron are equal to each other. Please take notes. When an element is uncharged, the number of proton and electron are the same. When an element is uncharged, the number of proton and electrons are the same. When an element is uncharged, the number of proton and electrons are the same. When an element is uncharged, the number of proton and electrons are the same. 11, 11. How do we get number of neutron again? 23 minus 11, 12. So number of neutron is atomic mass minus atomic number. Number of neutron, atomic mass minus atomic number. That's the number on top minus the number below. 23 minus 11, you have 11. Let's look at chlorine, proton, neutron, and electron. Proton is 17. The number below here is always the proton, 17. Neutron is 35.5 minus 17. Atomic mass minus atomic number, which is 18.5. Electron is 17, class. Remember I told you, when element is uncharged, number of proton and electron are equal. When an element is uncharged, the number of proton and electron are the same. When an element is uncharged. But class, let's now look at sodium and chlorine when they become charged. Class, when elements become charged, nothing happens to their proton and neutron. 11, 12. Class, so whether an element is charged or uncharged, number of proton and neutron does not change. Whether an element is charged or uncharged, proton and neutron does not change. I explained this last week, right? When an element is uncharged or charged, number of proton and neutron does not change. It's the electron that changes. It's the electron that changes. Why does electron change? I told you last week that among the three particles of elements, proton, neutron, and electron, are three particles. Among these three particles of elements, these first two are safeguarded inside the nucleus. Plus, these first two particles of elements are safeguarded deep inside the nucleus of the atom of the element. The proton and the neutron are hidden deep inside the nucleus of the atom of the element. So they cannot be lost or gained. They don't change, their value does not change. Because they are well kept. In fact, because they are well kept, they are the ones that make up the atomic mass of an element. Look up. What's atomic mass? Proton and neutron. Nobody mentioned electron because electron cannot be trusted. Nobody mentions, when you want to calculate the mass of an atom of an element, nobody mentions electron, just proton and neutron. Why don't you mention electron? Electrons cannot be trusted. Electrons cannot be trusted. We only mention proton and neutron. Why can't electrons be trusted? Electrons are not safe inside the nucleus. Electrons are found orbiting around the shells. Electrons are found orbiting around the shells of the atom of the element. Electrons are found outside. Plus, something you store inside and something you store outside. Which one can easily get lost? The one outside, right? The ones outside can easily get lost. So because electrons are outside, you cannot trust them. They can easily be lost or gained anytime. That's why we don't include them in the atomic mass. Because their numbers keep changing. They can either be lost or gained. Electrons can easily be lost or gained. So we can't trust electrons. This is why proton and neutron does not change, whether the element is uncharged or charged. Look at proton 11, proton 11. Neutron 12, neutron 12. Proton and neutron does not change, whether it's charged or whether it's uncharged or charged. The person that changes is electron. Electron will change. Plus, uncharged sodium means that it still has 11 electrons. Charged sodium plus 1 means he has lost 1 electron. So from 11 minus 1 becomes what? 10. Number of electrons has reduced from 11 to 10. So class, watch out in the exam. If someone has to define number of proton, neutron, and electron for sodium, check very well. Is it the uncharged sodium or charged sodium? Many students will give this answer for this. They don't really understand the difference between uncharged sodium and charged sodium. When sodium is uncharged, the number of proton and electron are equal. Neutron is 12. When sodium becomes charged, it means he has now lost 1 electron. Plus, charge on an element shows that he has either lost or gained electron. If the charge is positive, it means he has lost. If the charge is negative, it means he has gained. If someone is carrying a positive charge, it means he has lost electron. If someone is carrying a negative charge, it means he has gained electron. I hope you are following. If you are following, type I am following, sir. If you are following, type I am following, sir. If this will be your last jam, type this will be my last jam. Type it in the comment section. Let's keep going. So you understand why electron changed from 11 to 10 here. Let us go to chlorine now. Class, uncharged chlorine. Uncharged chlorine is, proton is 17, neutron is 18.5. How do we get 18.5? 35.5 minus 17, 18.5. Electron is also 17. Note that proton and electron are equal when the element is uncharged. When the element is not charged, proton and electron are equal. Don't forget, in case I'm too fast, rewind the video. Don't need to type, I don't understand. Don't need to type, sir, you are too fast. Just rewind the video and watch again. You have the power. Online class, your student has the power in an online class. Let's go. What happens to charged chlorine? What happens to charged chlorine? Class, charged chlorine, proton and neutron will not still change. Remember I told you, whether you are charged or uncharged, the number of proton and neutron are same. They don't change because they are stored deep within the nucleus. Proton and neutron does not change. It's electron that will change. Class, uncharged chlorine has 17 electrons. But what happens to charged chlorine? Minus means you have gained in chemistry, right? Plus means you have lost. Minus means you have gained. So minus 1 means chlorine has gained 1 extra electron. So from 17, you're going to add 1 electron. Chlorine now has 18 electrons. Chlorine now has 18 electrons. Class, with this explanation, the solution to this assignment will now be very easy. Watch how we just easily solve the assignment and nobody will be lost. Nobody will be lost. If you follow this very well, you see that I almost did a recap of last week's class already for you. If you are following me very well, you have already done a recap somehow of last week's class for you, although not everything. Still go and watch last week's class. We did not do purity. Remember we did pure sultan and impure sultans. Go and watch last week's class. Now, having understood this, let's do the assignment and now forge ahead. Let us do the assignment and forge ahead. Let us do the assignment and forge ahead. The first assignment is fluorine. And we have already brought up fluorine. Fluorine is 19 atomic mass and 9 atomic number. So number of proton for fluorine is 9. Number of neutron for fluorine. Neutron is atomic mass minus atomic number. 19 minus 9, 10. And number of electron is 9. Don't forget, when the element is uncharged, the number of proton and electron are the same. When the element is uncharged, number of proton and electron are the same. Class, for fluorine, just like every other element, wants to be like the noble gases. Let us consider the current configuration of fluorine. Fluorine is 2 in the K shell. Don't forget, if fluorine has 9 electrons, 2 will go to the K shell. How many is remaining out of, if 2 has gone to K shell, out of 9, how many is remaining out of 9? 7 will go to the L shell. 7 will go to the L shell. But class, this L shell, is it happy? No, L shell is not happy. Why? L shell needs 8 electrons to be happy. But fluorine is giving him 7 electrons. What must fluorine do to make L shell happy? What must fluorine do to make L shell happy? Fluorine must go and look for 1 electron to gain. Fluorine must go and look for 1 electron to do what? Gain, to make it 8. But when fluorine gains 1 electron, fluorine now becomes minus. I remind you again, when elements gain electron, they become minus. In chemistry, when an element gains electron, it becomes. So minus 1 means it has gained 1 electron. Therefore, the number of electrons for charged fluorine is now 10. The number of electrons for charged chlorine is now 10. But proton is still 9, neutron is still 10. Proton is still 9, neutron is still 10. Remember that proton and neutron does not change whether you are uncharged or you are charged. Proton and neutron does not change, only electron changes. So when fluorine was uncharged, number of electron was 9. When fluorine became charged, number of electron is 10. We have just done fluorine. I will clean the board now so we don't slow down. If you have not gotten it, rewind and watch again. Rewind and watch again. Let's not slow down. Jamb is 52 days away. No time to waste. Jamb is 52 days away. You have not joined our private class, message me on WhatsApp. You will miss a lot. You will miss a lot. I will soon open our Jamb camp, Jamb online camp, where you are going to delete your TikTok, delete all your social media and focus on Jamb. Jamb online camp. We are going to brainstorm every day till Jamb exam day. You are going to brainstorm every day till Jamb exam day till you pass your Jamb. Jamb online camp. The Jamb Master online camp. It works for our students every year. The Jamb Master online camp. We're going to camp you. Just like you go for camp in your church, Easter camp, this one camp, retreat. We're going to do Jamb online retreat, Jamb online camping. You're going to delete your TikTok before you join that group. You will show me proof that you have deleted your TikTok. You delete all your social media and focus on Jamb. After Jamb, enjoy your TikTok because you have gotten your admission. After Jamb, enjoy your TikTok because you have gotten your admission. If you're not in my private class, you will not be in the Jamb online camp. Message me, sir, I want to join your class. I like your energy. I want to join your Jamb master class. Message me. What will it take? I'll pay. I can pay any amount. Nothing is too much for my success this year. What is up, sir? Let me join your class. Message this WhatsApp now, sir. How can I join your private class? I know they are paying. I will pay. Those people that pay, they don't have 2x. I will pay too. I want to pass. Message me. Let's get going. Second assignment, boron. Don't forget, boron. What number does boron fall on the element table? What number does boron fall on the element table? Boron is number 5. If you count your first 20 elements, hydrogen, helium, lithium, beryllium, boron. Number 5 means that odd number. Atomic number is odd. What do? Multiply it by 2 and add 1. 5 times 2, 10. 10 plus 1, 11. From the atomic number, you can easily get the atomic mass. If the atomic number is odd, multiply it by 2 and add 1. If the atomic number is even, multiply by 2, don't add 1. When the atomic number is even, multiply by 2, don't add 1. But when the atomic number is odd, multiply by 2, then add 1. You have the atomic mass. So 5 times 2 is 10. 10 plus 1 is 11. Now let's look for the number of proton for boron. Proton is 5, obviously. This number here always stands for proton. Atomic number is 5. Neutron, how do you get neutron? 11 minus 5, 6. What of electron? Electron is the same thing with proton, right? 5, 5. Anytime the element is on charge, proton and electron are the same. Now, is boron happy with the shells? Let us see. What is the electronic configuration for boron? Boron is 2 on the K shell. Since he has 5 electrons, 2 will go to the K shell. Remember, they start filling from K shell first. So 2 will go to the K shell, and 3 will go to the L shell. 2 will go to the K shell, 3 will go to the L shell. 2, 3. And class, what does this mean? L shell is not happy with boron. L shell is not happy with boron. K is 2. K is happy, but L is not. K needs 2, and boron gave him 2. L needs 8, boron gave him 3. For L shell to be happy with boron, boron has to go and find 5 electrons to add to this 3. For L shell to be happy with boron, boron has to find 5 extra electrons to add to this 3. Where will boron see 5 electrons? What element is ready to lose 5 electrons? It's very difficult. So he either has to look for 5 electrons to add, or give her the 3 electrons and release L shell. Give her these 3 electrons and release L shell. If someone is not happy, release the person. L shell is not happy, so release him. How can you release him? Collect your 3 electrons and give it out. Collect your 3 electrons from L shell and give it. But when you lose 3 electrons in chemistry, what do you become? When you lose in chemistry, you become positive, right? But you lost 3, so it will be B3 plus. Don't forget, when you lose, it's plus. I know it might be confusing, but when you lose, you should minus. Like in real life, when you lose, you are minusing, right? But in chemistry, when you lose, you are positive. So boron 3 plus. Why is it 3? Because you lost 3 electrons. So class, let us now find number of proton, neutron, and electron for boron 3 plus. For normal boron, we have proton is 5, neutron is 6, electron is 5. For charged boron now, proton is still 5. These guys don't change. Remember, I told you, I've said this several times. These 2 guys don't change, whether you are on charge or you are charged. They don't change. Electron is the guy that will change. Class, boron has lost 3 electrons. Don't be deceived by this plus, so I'm going to add plus to this, you'll be wrong. Boron has lost 3 electrons. So if he has 5 before, 5 minus 3, 2. So the number of proton, neutron, and electron for boron is 5, 6, 2. If you got this, type I got it. Those that attended our class last week, you got this assignment, type I got it, sir. If you got this assignment, type I got it, sir. I got it, sir. If you got the assignment, type I got it, sir. I got it, sir. I got it, sir. If you got the assignment, type I got it, sir. If you got the assignment, type I got it, sir. Yes. Let's keep going. Let's keep going. Let's keep going. We are ready for Jamb this year. Jamb, we hear what this year? Jamb, we hear what this year? The last assignment, magnesium. Magnesium is number 12 on the element table. Class, 12 is an even number. 12 is an even number. So how do you get the atomic mass? 12 times 2, 24. 12 is an even number. When the atomic number is even, multiply by 2, don't add 1. When the atomic number is even, multiply by 2, but don't add 1. But if it's odd, multiply by 2, then add 1. So we have atomic mass and atomic number now. Proton is 12, obviously. Any number you see here is proton, 12. Neutron is 24 minus 12. The number of neutrons is atomic mass minus atomic number. Number of neutrons is atomic mass minus atomic number. So 24 minus 12 is also 12. Electron is 12. Why? Because proton and electron is the same when the element is on charge. I've said this several times. When the element is on charge, number of proton and electron are the same. Class, what is now the electronic configuration for magnesium? If you have 12 electrons following the K element model, 2 electrons will go to the K shell and K is happy because K needs 2. 8 electrons will go to the L shell and L is happy because L needs 8. 2 plus 8, 10. How many is remaining out of 12? Remaining 2. 2 electrons will now go to the M shell. M is not happy because M needs 8. M is not happy because M needs 8. So what will happen, class? What will happen if M shell is not happy? What must magnesium do to make M shell happy? He must go and find 6 to make it 8 or give her these 2 and release M shell. He must go and look for 6 electrons to make 6 plus 2 is 8 or give her these 2 electrons. Class, which one is easier? Elements are smart. It's easier to give her these 2 than go and looking for 6 whole electrons. Who will give you 6 electrons? Instead, let me just give her my 2 and release my M shell. But once magnesium gives her these 2 electrons, what does the magnesium become? It becomes Mg2 plus. When you lose, you are positive, don't forget. And the number of electrons you lose will now be the charge you will carry. When you lose electron, you become positive. And the number of electrons you lose will be the charge you carry. Mg2 plus. So let's now find number of proton, neutron, and electron for Mg2 plus. What will be the number of proton, neutron, and electron for Mg2 plus? Proton is 12. Neutron is 12. These guys don't change. Remember, these 2 guys don't. Whether you are on charge or charge, these 2 guys don't change. It's this guy that can easily be lost or gained. I've given you the reason already. 2 plus means he has now lost 2 electrons. Don't be deceived by these 2 plus and go and say plus 2. Some people will make that mistake in the exam. And trust Jamb to put a wrong option in the option there. And you will rush it. You know, it's very difficult for someone to convince you that you are wrong when the wrong answer you got is in the option. Class, you will be asking yourself, how did the examiner know that I will make this mistake? The worst thing that can happen to you is to get an answer and the answer is wrong, but the answer you got that is wrong is in the options. Class, it will be very difficult for anybody to convince you that you are wrong because I didn't know that I will get this exact answer. Did they see me in the dream? How did the examiner know that I will get this wrong answer and put it in the option for me? You always think that you are right because why did they put this answer in the option? If you solve wrongly and you don't see your answer in the option, you know you are wrong, right? But if you solve wrongly and the wrong answer you got is inside the option, it will be very hard for someone to convince you that you are wrong. You will go and tick it, say, how did they know that I will get this mistake? How did they plan for my mistake? Class, a good examiner plans for a student's mistake and put some of your mistakes in the option so you will rush and pick it. Be very careful. Some students will see this plus and say 12 plus 2, 14, the electron is 14. No. This plus actually means minus, he has lost. 12 minus 2, 10. Ladies and gentlemen, I will not talk about proton, neutron, and electron again. I've exhausted it very well. I have broken it down. If you miss any question on this in Jamb, then you cannot blame me, you cannot blame anybody. You only have yourself to blame. So class, good luck. Let me now move to something else. I have taken enough time and broken down the concept of elements, atoms, proton, neutron, and electron. It's now time to forge ahead. If you are with me, say forge ahead, sir. If you are still with me, you have not left. Remember your promise, sir. I will not leave till the end. Remember you told your parents that if you leave the class, they will not be able to join again. I will not leave till the end. If you are still with me, say, sir, forge ahead. We are with you. Sir, fire down. Sir, fire down. Sir, fire down. Last week we did 200 minutes challenge. Our students laughed with us on Sunday night for 200 minutes. I was so proud. Class, let's see how far we can go today. Say, forge ahead, sir. Forge ahead, sir. Sir, fire down. We know they go anywhere. Sir, fire down. Today, not today. Sir, fire down. 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 We are not living here today. Class, the topic is actually elements, compounds, and mixtures. We are now allowed to clean elements. We have finished, we have exhausted elements. Class, we have exhausted with thought element, broke down atoms, proton, neutron, we have broken it down. Let's now deal with compounds. Let's deal with compounds now. Write down, a compound is a substance formed. A compound is a substance formed. A compound is a substance formed Make sure you are writing a compound. A compound. This 15 minutes live so far. We are almost reaching 1 hour. We are doing more than 200 minutes today. Last week was 200 minutes. Let us go, guys. Guys, let us go. A compound is a substance formed when two or more different elements. A compound is a substance formed when two or more different elements. When two or more different elements are chemically joined together. A compound is a substance formed when two or more different elements are chemically joined together. They are formed as a result of chemical change. Hope you are writing. Hope you have a chemistry note with you there. I hope you are not pressing your phone. Hope you are writing. This is your Jamb you are talking about. 52 days to Jamb. No time to waste. Make sure you are writing. Your colleagues are writing. Make sure you are writing. Your colleagues are online. Make sure you have not left to. A compound is a substance formed when two or more different elements are chemically joined together. They are formed as a result of chemical change. They are formed as a result of the chemical change. They are formed as a result of chemical change. Example of a compound, we have calcium triazocarbonate. Example of a compound, we have calcium trioxocarbonate. Calcium trioxocarbonate, that's CaCO3. Plus, a compound is for combination of two or more elements. Thank God we just finished elements now, right? We just finished elements now. So what's a compound? Combination of two or more elements chemically joined together. Chemically joined together is a compound. Please take notes. Other examples of compound, we have calcium triazocarbonate, we have water. Water is H2O. Water, sand. Sand is a compound, are you aware? Silicon dioxide. Limestone is a compound. Okay, we have already done limestone, which is calcium triazocarbonate. This calcium triazocarbonate is also called limestone. Calcium triazocarbonate is also called limestone. Lime water is a compound. Lime water. What is lime water? CaOH2. Calcium hydroxide. Sugar is a compound. In case you ask, which of is not a compound? Sugar is a compound. What makes up sugar? C6H12O6. Soap is a compound. Soap. Your regular soap you use soap is a compound. What makes up soap? C17H35COONA. Class, these are examples of compounds. These are examples of compounds. If you notice one common thing about all these compounds is that they are only made up of elements. I want you to take note, and they are combined chemically. So the components of a compound cannot easily be broken down by any physical means. The components of a compound cannot be broken down by physical means because they were not joined physically, they were joined chemically. They were joined chemically. Please take note. Class, that's compound for you. Let's now go to mixtures. Let us go to mixtures. In case I was too fast, the wine and rush, you can pause and write down. But we cannot wait for you because there's no time. Mixtures. Mixtures. So we have done compound now. Let's look at what is a mixture. What is a mixture? A mixture contains two or more constituents. 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 Make sure you're writing. Which can easily be separated by physical means, by physical method. A mixture contains two or more substituents, which can easily be separated by physical method. A mixture contains two or more constituents, which can easily be separated by physical method. Make sure you are still there. Don't allow any sleep to catch you. Don't allow any sleep to catch you. If you snooze, you lose. If you snooze, you lose. If you snooze, you lose. Pour water in your face if you are feeling sleepy. Pour water on your face if you are feeling sleepy. If you snooze, you lose. If you snooze, you lose. Pour water in your face if you are feeling sleepy. If you snooze, you lose. Make sure you are not sleeping. A mixture contains two or more constituents, which can easily be separated by physical method. Note, the constituents of a mixture can either be elements or compounds or both. The constituents of a mixture can either be elements or compounds or both. The constituents of a mixture can either be elements or compounds or both. Now let's look at the difference between mixture and compound. Write down difference. Difference between mixture and compound. Difference between mixture and compound. M is for mixture, C is for compound. Difference between mixture and compound. Let's go. Difference between mixture and compounds. Mixtures may be homogeneous or heterogeneous. Mixtures may be homogeneous or heterogeneous. Mixture may be homogeneous or heterogeneous. Compound always homogeneous. I explained last week already what is homogeneous and heterogeneous, right? I explained last week what is homogeneous and heterogeneous. Compound is always homogeneous. Compound always homogeneous. 2. Easily separated by physical means. Mixtures are easily separated by physical means. Mixture is easily separated by physical method. Compound cannot be separated by physical method. Cannot be separated. Cannot be separated by physical method. Cannot be separated. Compound cannot be separated by physical methods. 3. Mixture cannot be represented by chemical formula. Mixtures cannot be represented by chemical formula. A compound can be represented by a chemical formula. Compound can be represented by a chemical formula. Four. Okay, let's give you this 3. 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 When you're done writing, we'll go to separation techniques. Class, if you look at the number two say easily separated by physical method. So mixtures can be separated by physical method, but compounds cannot be separated by physical method. Congratulations, guys. We just clocked 1 hour. This is 60 minutes. Look at your time on the screen. This is 60 minutes. This is 60 minutes. This is 60 minutes. This is 60 minutes. This is 1 hour exactly. If you stayed from the beginning till now, type yes, sir. I was there. I have not left. Type yes, sir. I have not left. I have not left. If you have been here from now to this 1 hour, so we have clocked 1 hour challenge. Let us go for 2 hours. 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 We have clocked 1 hour challenge. Let us go for 2 hours. Class, as I was saying, mixtures can easily be separated by physical method. Why? Because they were joined physically, so they can be separated physically. But compounds cannot be separated by physical method because they were not joined physically. Compounds were joined chemically. So class, the next topic we're going to look at now is separation techniques. Separation techniques. Separation techniques. Class, what do we use separation techniques to do? To separate the components of a mixture. Since the components of a mixture can be separated via this physical method, separation techniques are those physical methods we use to separate the components of a mixture. Class, note, we don't use separation technique to separate the components of a compound. The components of a compound cannot be separated via separation techniques. We only separate components of a mixture by separation techniques. Let us go to separation techniques. Separation techniques. No time to waste. Separation techniques. No time to waste. Make sure you don't live to the end. We said we are not living to the end. Test yourself. Test yourself. Say, let me even push myself for once in this life. Let me push myself for once in this life. I am not living to the end. I know I like TikTok. I know I like TikTok. I like pressing my phone. I like WhatsApp status. But this jam, I want to pass it once and for all. I am not living till the end. I am not living till the end. I am not living till the end. Let us go to separation techniques. Separation techniques. These are techniques employed, right now. Separation techniques are techniques employed in separating the components of a mixture, making use of the physical properties of its constituents. I'll come again. Separation techniques are methods used. Separation techniques are methods used in separating the components of a mixture. Separation techniques are what? Methods used in separating the components of a mixture. In separating the components of a mixture, making use of the physical properties of their constituents. Making use of the physical properties of their constituents. Making use of the physical properties of their constituents. Making use of the physical properties of their constituents, Making use of the physical properties of their constituents, such as difference in solubilities, boiling points, sublimation. Making use of what? Making use of physical properties of their constituents. Making use of physical properties of their constituents, such as difference in solubilities, boiling points, sublimation, rates of diffusion, rates of movement over an adsorbent medium, rate of movement over an adsorbent medium, rate of movement over an adsorbent medium, rate of movement over an adsorbent medium, or the magnetic properties. Class, these are the physical properties that we make use of When what? Separating components of a mixture. When separating components of a mixture, come again, making use of what the physical properties of their constituents, such as difference in solubilities, boiling points, sublimation, rates of diffusion, rate of movement over an absorbent medium, or magnetic properties. Without wasting more time, let us go to the first separation technique. Let us go to the first separation technique in chemistry. Without wasting more time, let us go to the first separation technique in chemistry. Without wasting more time, let us go to the first separation technique in chemistry. Class, the simplest separation technique in chemistry is sieving. And it's also very common and relatable. You have probably sieved before. Everybody watching this live, one time or the other, you have either sieved before or you have watched someone sieved. Sieving. Now write down. Make sure you're writing material. Make sure you're with your writing material. Sieving is a method used to separate solid particles of different sizes. Sieving is a method used to separate solid components of different sizes. Sieving is a method used to separate solid components of different sizes. Sieving is a method used to separate solid components of different sizes. Make sure you are following. Make sure you are following. Sieving is a method used to separate solid components of different sizes. Sieving is a method used to separate solid components of different. The particles are placed on a sieve with a mesh of a particular size. The particles are placed on a sieve. The particles are placed on a sieve. The particles are placed on a sieve with a mesh of a particular size. The particles are placed on a sieve with a mesh of a particular size. Now the particles smaller than the mesh size, the particles smaller than the mesh size of the sieve will pass through. The particles smaller than the mesh size of the sieve will pass through. The particles smaller than the mesh size of the sieve will pass through, while the bigger particles will remain on the sieve. While the bigger particle will remain on the sieve. So class, I believe even without explaining this sieving, everybody should know what a sieve is now. You separate a bigger particle from a smaller particle. For example, you put rice and beans in the same place. There's a kind of sieve that you put the rice and beans inside. The rice will come down, the beans will still remain on top, right? Because beans, they are bigger, they are wider. Beans will not pass through all sieves, but the rice can pass through some sieves. Do you get? Or say, well, rice and gari, the rice will remain, the gari will pass through. You know what I'm talking about? Sieving. Let's not waste time here, let's move forward. There are more tougher things to learn. There are more tougher things to learn, but I also want to show you that we're going to teach you everything in your chemistry step by step. Please, in case you missed any part, rewind the video or pause it. This is an online class. Don't say, sir, I'm still writing. Rewind the video. Some of you are still used to a physical class. Just rewind the video, you will get it. Rewind the video or pause the video and write it down. So we'll not be waiting till you finish writing. There's no time. Let's go to the next one. Magnetic separation. Magnetic separation. Magnetic separation. This method is used. Magnetic separation. This method is used to separate magnetic properties. Different sizes. Magnetic separation. This method is used to make sure you are writing. We are now on 70 minutes. You don't know what you are gaining here. You don't know what you are achieving here. Some of you don't know what you are achieving yet. This method is used to separate magnetic substances from non-magnetic particles. This method is used to separate magnetic substances from non-magnetic particles. That is magnetic separation. Number 3, let's go to sublimation. If you missed it, please rewind the video and watch again. There is no time. Let's go to sublimation. 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 This method is used, make sure you are writing. This method is used. Sublimation. This method is used to separate solids which sublime on heating. This method is used to separate solids which sublime on heating. This method is used to separate solids which sublime on heating. These solids, when heated, also change directly to their gaseous states without going through the liquid state. Yes, very important. I'll come again. These solids, when heated, make sure you are writing. I'm coming closer to the phone so that you can hear my voice because I'm dictating. These solids, when heated, change directly to their gaseous states without going through the liquid states. These solids, when heated, change directly to their gaseous states without going through the liquid states. Imagine something changing from solid straight to gas without going through liquid. Imagine something changing from solid to gas straight without going through liquid. That substance is called a sublimable substance. Sublimable substance. That substance is called a sublimable substance. Without going through the liquid phase. Without going through the liquid phase. That substance is called a sublimable substance. Sublimable substance. What are examples of sublimable substances? What are examples of sublimable substances? Hope you are still there. Make sure you are not left to. If you snooze, you lose. What are examples of substances that sublime? We have iodine. We have ammonium chloride. They can ask you in Jamb. You could be asked in Jamb. Which of the following substances is not sublimable? You must first know the ones that are sublimable first. You must first know the ones that are sublimable. Ammonium chloride is sublimable. Iron 3 chloride is sublimable. Sulfur is sublimable. Benzoic acid, sublimable. Write these examples down. So they ask you in Jamb, which of the substance is not sublimable? You will know the one to choose. What is a sublimable substance? A substance that changes from solid. Normally, a substance should go from solid to liquid, then to gas, right? A substance should go from solid first to liquid, then to gas. But any substance that bypasses liquid and goes to gas direct is sublimable substance. They are termed sublimable substance. When a substance goes from solid to gas straight, without passing through liquid, is sublimable. Sublimable. And the process is called sublimation. That process is called sublimation. The process by which a solid changes to gas without passing through the liquid is called sublimation. Who can tell me the name of the process When a substance changes from gas straight to solid without passing through liquid. Class, follow me. Solid straight to gas is sublimation. Solid straight to gas is sublimation. What is gas straight to solid without passing through liquid? What is gas straight to solid without passing through liquid? What is it called? If solid straight to gas is sublimation. If solid straight to gas is sublimation. What is gas straight to solid without passing through liquid? Drop in the comment section. Let me see my best chemistry student. Don't go and ask Google though. Think with your brain. If you are always going to ask Google for everything, it will affect you in exam day. They will ask you question 1, you will think of Google, and there's no Google in Jamb day. Use your brain. Use your brain. If you don't know, it's better you fail it and correct yourself. Don't go and use ChatGPT. Don't go and use Google. Don't go and use AI. Think with your brain. If you don't know it, teacher will teach you instead of going to use Google. In your exam day, they will not be Google. They will not be ChatGPT. Think with your brain. What is the process called when a gas goes to solid without passing through liquid? A solid goes to gas without passing through liquid is called sublimation. Yes, we agree. When a solid goes to gas without passing through liquid is called sublimation. We agree. What of when a gas now goes to solid without passing through liquid? What is it called? I will drop the answer soon, but let us continue. So sublimation is a type of separation technique. So when we use this to do sublimation, we use to separate sublimable substance from non-sublimable substance. We use sublimation to separate sublimable substance from non-sublimable substance. And we are giving you an example of sublimable substance. Class, anytime you see any of these substance in the exam, and they say, what method of separation technique is used to separate iodine from this? Class, sublimation must be involved. Because iodine is sublimable, so it is wise to use sublimation to bring out the person that is sublimable. Are we together? Let's go to the next separation technique. Before we do that, let me give you the answer to this. From gas straight to solid is called deposition. Take note. Don't forget. I have not checked the comment section if anybody got it, but let me know. Did anybody get the comment section? If you got it, say I got it, sir. If you got this, say I got it, sir. From gas straight to solid without passing through liquid is called deposition. It's called deposition. It's called deposition. Let us keep going. No time. No time. I would love to come and check who got it, but there's no time. Your Jamb is more important than who got it. Your Jamb is more important than who got it. 52 days to Jamb. No time to dull. Let's go. Let's go to the next separation technique. Fractional distillation. Fractional distillation. Fractional distillation. Fractional distillation, 52 days to Jamb, 52 days. $52 to Jamb. If you live this life, you're on your own. I don't know what is more important than your Jamb. That you have already bought Jamb form. You want to dash Jamb money next year again, Abi? You better don't live this life. That spirit that's telling you to go and sleep now. Don't worry, you have tried now. Don't listen to that spirit. Jamb in 52 days. We want to be buying Jamb form every year. You want to be buying Jamb form every year, right? You better sit up, pour water in your face if you are finished sleeping. Tell yourself, I must pass my Jamb this year. You better sit up 52 days to Jamb. Don't go and buy Jamb form next year. I don't want to see you in my class next year. I don't want to see anybody here in my Jamb class. You should be in year 1 next year. We should be celebrating your admission next year. Some of you should be inviting me for your matric. I will come. Be inviting me for your matric. I go for my students' matric to go and celebrate what I taught them when they passed. I want to see your matric invitation next year, matriculation. When you enter 100 level, they will matriculate you. You will be matriculated. I want to see your invitation to your matric. Invite me for your matric, because you will be getting medicine and surgery. You are getting nursing this year. You are getting pharmacy this year. You are getting engineering, computer science, biochemistry this year. Medical laboratory, physiotherapy, whatever course you are applying for, architecture, whatever course, engineering, whatever course you are applying for, it is this year. They will not change your course. So go and wash your face now. Go and wash your face. I don't want to see that you are sleeping. Plug your phone to power bank. Collect someone's power bank. Plug your phone. Don't tell me your battery is low. Don't tell me your battery is low. Let's go. 52 days to Jamb. Fractional distillation. Class, we have normal distillation and we have fractional distillation. So before we go look at this distillation, there's what we call simple distillation. There's what we call simple distillation. Let me first explain what happens in distillation class. Normally we use distillation to separate, right down. Distillation, simple distillation is used to separate two miscible liquids with different boiling point. We use distillation to separate two miscible liquids with different boiling point. Miscible liquids, miscible. Who are miscible liquids, class? Miscible liquids are liquids that dissolve in each other. Miscible liquids are liquids that dissolve in each other. That means when you mix the two liquids together, you will not see any difference. You will just think there is only one liquid that is there, but there are two. If you put water inside alcohol, you will not meet any difference, class. You pour small water inside alcohol, you will not even know that there's another liquid inside this liquid. But if you pour red oil inside water, or you pour water and red oil together, you will know, right? You will know that there's red oil inside this water, there's red oil inside this water. So water and red oil are not miscible, but water and alcohol, they are miscible. So it is very difficult to even separate them because they are inside each other. The only thing you can do is to use difference in their boiling point. If two liquids have different boiling point, class, what happens? Class, are you aware that anytime a liquid reaches boiling point, changes to gas? Anytime you boil a liquid to its boiling point, it will change to gas. Are you aware? Anytime you boil a liquid to its boiling point, it changes to what? Gas. Let us say you have water and ethanol. You have water and what? Ethanol. Now the boiling point of water is 100 degrees Celsius. Boiling point of ethanol is 78 degrees Celsius. You want to separate them. So in this mixture here, you have water and ethanol. You have water and you have ethanol, and you want to separate them. And you start eating and you apply it. You apply what? Heat. You start eating them up, So from 0 degrees Celsius it goes to 20, from 20 it goes to 50, 50 it goes to 60, 60 it goes to 78. What will happen at 78? Class, the boiling point of ethanol is 78. At 78, ethanol will start coming out to turn into gas. Ethanol will change from liquid to gas. Class, what you have to do is to connect a condenser to this system. Collect a condenser. The popular condenser we use is Liebig condenser. Liebig condenser. Liebig condenser is the popular condenser we use. What's the work of the condenser, class? If you don't put a condenser here, the ethanol will turn to gas and escape to the atmosphere. We will not get it. The ethanol will turn to gas and escape to the atmosphere. We will not get it. But what does a condenser do? A condenser will change a gas back to liquid in another container. The condenser will collect all the ethanol gas that is coming out and bring it into another container. So we can have ethanol here. So that only water is remaining here. When you get to 78 degrees Celsius, water cannot come out. Why? Water only starts boiling at 100 degrees Celsius. So you are sure that every gas that is coming out at 78 is what? Ethanol. So you collect your ethanol separately and water is the one remaining here. And you have separated water and ethanol. Class, if you try using filtration, it will not work because the water and ethanol have mixed inside each other. Two of them will come out. If you use any other method, they will not work. The only method that can work is distillation. In distillation, we apply heat to the two liquids until one of the liquids starts coming out as gas. Connect a condenser so that condenser changes gas back to liquid and bring it to another container. The condenser will collect the gas that is coming out so it doesn't escape and waste because gas can run anywhere. The condenser collects the gas and brings it into another container so the gas does not waste. The condenser changes the gas back to liquid in fact. So you still have ethanol liquid. Ethanol gas will come out here at 78 degrees Celsius, but the condenser will change the gas back to liquid and it's collected in another container. This is what happens during distillation, simple distillation. But when do we now apply fractional distillation? Plus, when you have several components with different boiling points, you can no longer use simple distillation. Simple distillation can still separate just 2 or 3 components with different boiling points. But when they are more than 2, they are more than 3, you have to apply fractional distillation. In the exam, they usually ask that what's the difference between fractional distillation and simple distillation? Class, in fractional distillation, a fractionating column is introduced. Take note. In fractional distillation, a fractionating column is introduced to the system. A fractionating column is introduced in a system. So class, my point is this. Whether it is fractional or simple distillation, they follow the same process. Apply it until the one person gets to its boiling point, it starts turning to gas, right? A condenser changes that gas back to liquid and brings it for you. But when we use fractional distillation, imagine there are 10 liquids here, class. You cannot use simple distillation. Why? How will you separate each of the components? You know, there are 10 liquids and they have different boiling points. A fractionating column is introduced in a fractional distillation so that they can calculate separating each of them. Okay, this A, B, a fractionating column to separate each of, because if you use simple distillation, separate 10 different liquids. Class, you're going to have a problem. Some liquids will mix into another liquid. So you apply a fractionating column. That's the major difference between fractional distillation and simple distillation, but they apply the same principle. Are we together? Now another thing with fractional distillation is this, class. When the boiling points are so close to each other, simple distillation you cannot use it, you use fractional distillation. When the boiling points are very close to each other, you cannot use simple distillation, use fractional distillation. Class, water and ethanol, the boiling point is still far away somehow. 178, they are still far away. When the boiling points are close, for example, the components of crude oil. Class, all the components of crude oil, their boiling points are close to each other. We use a fractional distillation. So in the exam, they ask you which method is used to separate liquids of close boiling point. Is fractional distillation. But if they ask you simply, what method is used to separate liquids of different boiling point, they do not put close. If they say, what method is used to separate 2 or 3 liquids, just 2 or 3 of different boiling points, just choose distillation, choose distill, don't go for fractional. But they now specify and say what method is used to separate liquids of close boiling point, whether they are 2. Even if they are just 2, but they are close, they are too close, it's fractional. Please understand the difference. If they are close, fractional. But if they just say different boiling point, I mean they are different, they are not close, just choose normal distillation. Class, they can ask you in your Jamb, what method of separation technique is used to what? Purify water, town water supply. In the treatment of town water supply, what method is used is distillation. The answer is distillation. Distillation is used in treatment of town water supply. Is a popular Jamb question. What method, which of the following is used to in the treatment of water, town water supply? Answer is distillation. As we're teaching you, I'm preparing you for exam, don't forget. I hope you have understood distillation and fractional distillation now. Please never forget it. Never forget it. Now write down separating funnel. Separating funnel. If you are following this class so far and you already believe, you have faith that with this class I will pass my Jamb, say I believe, sir. If you believe that with the way we are teaching you step by step, you will blast chemistry, you will blast physics. Say I believe, sir. Say I believe in the comment section. Say I believe, I believe. With the way they are teaching us step by step. With the way they are teaching us step by step. See how they are breaking things down. Say if you believe you will pass your Jamb now. Say I believe, I believe, I believe. Say I believe in the comment. Make sure you have not left to 52 days to Jamb. Go and wash your eyes. Make sure you have not left. Separating funnel is used to separate two immiscible liquids. Two immiscible liquids. Class. Before now, I told you about miscible liquids. Please don't confuse miscible with immiscible. Do not confuse miscible with immiscible. Do not confuse miscible liquids with immiscible liquids. What are immiscible liquids? These are liquids that don't dissolve in each other. Immiscible liquids, these are liquids that don't dissolve in each other. Immiscible liquids, these are liquids. Hope you are writing. Immiscible liquids, these are liquids that don't dissolve in each other. Immiscible liquids. These are liquids that don't dissolve in each other. What are examples of immiscible liquids? Water and kerosene are immiscible. Water and red oil are immiscible. These are liquids that don't dissolve in each other. Immiscible liquids are liquids that don't dissolve in each other. One method is used to separate them, separating funnel. Please take note. Separating funnel. Jamb exam, separating funnel. Let's move forward. Separating funnel. In case you didn't get it, rewind the video. Don't forget, rewind the video and watch again. 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 Filtration. Let's look at filtration. Filtration. This method is used for separating an insoluble solid from the liquids through the pores of a filter paper. This method is used for separating an insoluble solid from its liquids through the pores of a filter paper. This method is used for separating what? An insoluble solid from its liquid through the pores. What are pores? P-O-R. Like pores means holes, small holes are called pores. Through the pores of a filter paper. Used to separate what? An insoluble solid from its liquids through the pores of a filter paper. Note, the liquid which passes through the filter paper is known as the filtrates. The liquid which passes through the filter paper is known as the filtrates. The liquid which passes through the filter paper is known as the filtrates. The liquid which passes through the filter paper is known as the filtrate. The liquid which passes through the filter paper is known as the filtrate. The liquid which passes through the filter paper is known as the filtrate. While the solid particles remaining in the filter paper is the residue. While the solid particles remaining in the filter paper is known as the residue. While the solid particles remaining in the filter paper is known as the residue. While the solid particles remaining in the filter paper is known as the residue. Residue. You could be asked in your exam, the liquid that passes through the filter paper is the filtrate. The solid remaining in the filter paper is the residue. What are examples of mixture that can be separated by this? What are examples of mixture that can be separated by this? A mixture of chalk dust and water. A mixture of chalk dust. Make sure you are writing. A mixture of chalk dust and water. A mixture of chalk dust and water. A mixture of chalk dust and water. A mixture of sand and water as well. A mixture of sand and water. A mixture of sand and water. A mixture of sand and water. Class, what happens is this. You have a funnel and you have a container. Inside the funnel you have a filter paper. So you turn in your mixture of chalk dust and water. If you turn in your mixture of chalk dust and water, what happens? The filter paper traps the chalk particles. The filter paper will trap the chalk particles. When you pour a mixture of chalk and water into this filter paper will trap the chalk particles and the water will come down. The water that comes down is the filtrate. The chalk dust that remains here is the residue. So the chalk dust is insoluble in the water. That's why you use filtration. Please take note. The key word in filtration, you use to separate what? An insoluble solid from its liquids. Who is an insoluble solid? Chalk in water. Class, if you pour chalk inside water, you will still see the chalk. If you pour sand inside water, you will still see the sand, right? Because the sand and the chalk did not dissolve in the water. The sand and the salt did not, the sand and the chalk particle did not dissolve inside the water. So you can still see the sand inside the water. So if you pour a mixture of sand and water inside this now, the filter paper can trap the sand or the chalk while the water will escape the filter paper. Water can pass anywhere. Water no get enemy, right? Water no get enemy. Water can pass through any. So the water will pass through the small holes in the filter paper and come down. The water that you got down is the filtrate, but the chalk dust or the sand remaining here is the residue. Filtration is only working because the chalk dust and the sand did not dissolve inside the water. They are insoluble. So if they ask you what separation technique is used to separate an insoluble solid from its liquid, it is filtration. Because the solid is insoluble. Take note of the word. The key word is insoluble. Insoluble. The solid did not dissolve in the water. What if the solid dissolve in the water? You cannot use filtration. For example, if it is salt and water. Plus, your normal kitchen salt, your table salt. If you put salt inside water, will you see the salt in the water? No. The salt will go and dissolve inside the water. So this salt and water is soluble. Class, if you pour salt and water inside this filter paper, two of them will pass through. Everywhere go first blow. Everywhere go first blow. Two of them will pass through. If you pour salt and water inside this filter paper, all of them will pass. None of them will be trapped. The filter paper cannot trap the salt. Why? The salt has dissolved inside the filter paper. The salt has dissolved inside the filter paper. So it cannot pass. Sorry, the salt has dissolved inside the water. The salt has dissolved inside the water. So the filter paper cannot trap it. The filter paper cannot trap the salt. But the filter paper can trap this chalk dust. It can trap the sand. Why? The sand and the chalk dust did not dissolve inside the water. So filtration is only used to separate insoluble, the people that did not dissolve. Those solids that did not dissolve. Insoluble solids from its liquids use filtration. But what do we now use to separate soluble solids from their liquids? Drop in the comment section, let me know. Let me know, my best chemistry students. What do we now use to separate soluble solids like salt? When salt dissolves in water, filtration cannot separate it. Filtration cannot separate it. I've told you the reason why, right? If you pour water and salt inside here, two of them will pass through. It will shock you. It will shock. Two of them will pass through. What method is then used to separate salt and water? Tell me in the comment section if you are still with me. Those that have left, I pity you. 52 days to Jamb. Go and sleep, don't worry. The people that will compete with you, that will looking for that same nursing you are looking for, they are still alive, they are still awake. You are going to sleep. You want nursing, but your friend that want nursing is awake, you are sleeping. Who will they give nursing? Your colleague that want nursing, she's still awake, she's learning. You are going to sleep and you want nursing. You want medicine and surgery, but you are going to sleep. You think doctors are lazy? You want pharmacy and you are sleeping. You have gone, they have left the class now, you have gone, but you want pharmacy. Yeah, let's see now. Go and wash your face, go and wash your face now. Class, the method which separates salt and water is evaporation. Evaporation. You want to separate a mixture of salt and water. Evaporation. 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 Class, when you have salt and water in a container, salt and water, what you can do is to apply it. Apply what? It. When you apply it to the solution, what will happen in salt and the water? When water gets to 100 degrees Celsius, what happens? it starts turning to gas. When water gets to 100 degrees Celsius, it starts turning to gas. If you still need the water, then connect a condenser. Connect a condenser if you still need the water. Because if you don't put a condenser, once water turns to gas, Otilo, it has escaped. It has gone. But if you want the water, collect a condenser. What does a condenser do? A condenser will change the gas water back to liquid and give you another container. And only the salt will be remaining here. Only the salt will be remaining here. The water will follow and enter this container if you put a condenser. If you don't put a condenser, the water has gone. Anything that has entered the atmosphere is for the atmosphere. It has gone. Are we together? This is a very simple way of what? Separating salt and water. It's called evaporation. It's called evaporation. It's called evaporation. Congratulations, guys. 100 minutes. 100 minutes. 100 minutes. 100 minutes. 100 minutes. You stayed till 100 minutes. Well done. If you have been here, you have not left. Say, sir, I have not left. If you have been here, you have not left once. Sir, I want that nursing. You think I'm joking? Sir, I want to get nursing this year. I want to get medicine and surgery this year. You have not left once. Say, sir, I have not left. Let me see your comments. Sir, I have not left this class. I have not left this class. Let me see your comments. Sir, I have not left. Congratulations, guys. 100 minutes. Sitting down and learning with the Jamb master. 100 minutes. Congratulations. Congratulations. We did it, guys. We did it. Let's go. Let's go for 200 minutes. Let us go for 200 minutes. Let us go for 200 minutes. Let us go for 200 minutes. Possible. Go and wash your eyes now. 52 days to Jamb. 52 days to Jamb. Go and wash your eyes. Pour water on your face and come back. Pour water on your face and come back. Anything, if you buy chewing gum, chew chewing gum or buy something that you train, don't miss the class. Make sure you don't leave. 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 Let's go to crystallization. Crystallization. Crystallization, write down. This is a method used to separate salts. Crystallization is a method used to separate salts which decompose easily on heating from other solutions. Crystallization is a method used to separate salts which decompose easily on heating from their solutions. Crystallization is a method used to separate salts which decompose easily on heating from their solutions. Crystallization is a method used to separate salts which decompose easily on heating from their solutions. Note, in crystallization, the salt solution is first heated. Note, in crystallization, the salt solution is first heated to evaporate some of the solvents. Note, in crystallization, the salt solution is first heated to evaporate some of the solvents. Note, in crystallization, the salt solution is first heated to evaporate some of the solvents. The solution then becomes saturated. The solution then becomes saturated. The solution then becomes saturated. Class, what is a saturated solution in chemistry? What is a saturated solution? What is a saturated solution? Follow me. What makes up a solution? What makes up a solution is solute and solvent. What makes up a solution is solute and solvent. What makes up a solution is solute and solvent makes up a solution. Solute plus solvent makes up a solution. Solute and solvent makes up a solution. Solute and solvent makes up a solution. Class, A saturated solution is a solution that has dissolved the number of solute it needs. Class, when a solvent has taken the exact amount of solute it needs, that solution is said to be saturated. Solvent is, for example, water is a universal solvent. The exact amount of solute that is needed for this water to be saturated, once it has taken it, the solution is said to be saturated. When we get solubility, I will explain better. So we say a saturated solution is a solution that contains as much solute as it can dissolve. A saturated solution is a solution that contains as much solute as it can dissolve. A saturated solution is a solution that contains as much solute as it can dissolve. A saturated solution is a solution that contains as much solute as it can dissolve. But we have two other types of solution. We have unsaturated solution and we have supersaturated solution. So I just explained to you saturated solution, right? Saturated. Class, the word saturate means fill up. When something is filled up, we say it's saturated. When something is filled up, we say it's saturated. So a saturated solution is a solution that contains as much solute as it can dissolve. A saturated solution is a solution that contains as much solute as it can dissolve. But an unsaturated solution contains less solute than it can dissolve. That means there's still space to take in more. Less solute than it can dissolve. But a supersaturated solution contains more solute than it can dissolve. More solute than it can dissolve. More solute than it can dissolve. I'll come again, but I was too fast. Unsaturated contains less solute than it can dissolve. An unsaturated solution contains less solute than it can dissolve. That means there is space for more. It doesn't have the full solute that it can dissolve. It has less than the number it can take. So the space to take in more. That's an unsaturated solution. But what's a supersaturated solution? This guy has taken more solute than it can dissolve. He has taken more solute than it can dissolve. Please learn that. But what is a saturated solution? This guy has taken the exact amount of solute it can dissolve. A saturated solution has taken the exact amount of solute it can dissolve. Let's keep going. Let's keep going. Let's keep going. Let's keep going. Class, remember that in chemistry we have what called the liquescent substance. We have what we call the hygroscopic substance. This is Jamb class, everything must be mentioned. And we have what we call a fluorescent substance. And we have what we call effervescent. Effervescent. We have 4 different types of substance in chemistry. 4 different types of substance in chemistry. 4 different types of substance in chemistry. There are 4 different types of substance in chemistry. The liquescent substance, hygroscopic substance, efflorescent substance, and effervescent substance. Can you give examples of each of them and the difference between each of them? If you can do it, say, "Sir, I can do it." If you can do it, say, "Sir, I can do it." Can you give examples under each of them? Okay, right now, if you don't know how to do it, let us learn. Let us learn. There's no time. There's no time. Let us learn. Remember, I came here. I'm not wasting time today. Write down. A deliquescent substance is a substance. Write down. Make sure you are writing. A deliquescent, the first one, deliquescent substance is a substance that absorbs moisture from the atmosphere. A deliquescent substance is a substance that absorbs moisture from the atmosphere and forms a solution. So when you expose the deliquescent substance to the atmosphere, it absorbs moisture. What is moisture? Moisture is water. Moisture is what? Water. Absorbs moisture from the what? Atmosphere to form a solution. absorbs moisture from the atmosphere to form a solution. Absorbs moisture from the atmosphere to form a solution. Absorbs what? Moisture. So when you expose the liquid substance to the atmosphere, it absorbs moisture from the atmosphere to form a solution. What are examples of the liquid substance, class? You could be asking, the example you're following is not a deliquescent substance. It's a popular Jamb question. Deliquescent, we have calcium chloride. Write down calcium chloride. We have sodium hydroxide. Example of deliquescent, we have calcium chloride, CaCl2. We have sodium hydroxide, NaOH. We have magnesium chloride, MgCl2. Examples of the liquescent substance, take note of them. When you expose these guys to the atmosphere, they will absorb water or moisture from the atmosphere until they form a solution. Let's go to the next one, hygroscopic substance. Hygroscopic substance. Let us go to the next one, hygroscopic substance. Class, hygroscopic substance also, when exposed to the atmosphere, write down. These are substances that when exposed to the atmosphere, they also absorb moisture. Hygroscopic substances also absorb moisture, but they do not form a solution. They absorb moisture, but they do not form a solution. They absorb moisture, but they do not form a solution. Example, we have concentrated sulfuric acid, H2SO4. Concentrated sulfuric acid. Concentrated sulfuric acid, H2SO4. We have silica gel, silica gel. Silica gel, another example of hygroscopic substance. We also have quicklime, quicklime. Quicklime is hygroscopic. Quicklime, hygroscopic. Quicklime, hygroscopic. They absorb water, but they do not form a solution. Let's go to efflorescent substance. What is an efflorescent substance? An efflorescent substance is a substance that loses water of crystallization. When exposed to the atmosphere, an efflorescent substance is a substance that loses water of crystallization. Loses water of crystallization. Loses water of crystallization. An efflorescent substance is a substance that loses water of crystallization. I hope you are still there. Hope you have not left. Hope you have not left. It loses water of crystallization when exposed to the atmosphere. Example, we have washing soda. We have copper 2 sulfates. We have washing soda. We have copper 2 sulfates. In fact, you write down hydrated copper 2 sulfate, the hydrated one. Class, copper 2 sulfates can either be anhydrous or hydrated. Class, there's what we call anhydrous. When a substance in chemistry is anhydrous, what does it mean? Anhydrous means that it doesn't have any water of crystallization. That means the dry form of a substance is anhydrous. For example, CuSO4 alone is anhydrous. But hydrated CuSO4 is CuSO4 .5H2O. This is hydrated. This is hydrated. So a substance can be hydrated when it has water of crystallization. This is the water of crystallization. 5H2O is called water of crystallization. So that's hydrated, but this was anhydrous without water. When someone does not contain water, it's anhydrous. When it contains water, it's hydrated. Class, it is the hydrated form that is fluorescent. Class, when you expose this kind of substance to the atmosphere, it will lose water of crystallization. It will lose water of crystallization. This guy will lose water. This guy will lose water of crystallization. It will lose water of crystallization. It will lose water of crystallization. Hydrated. It will lose water of crystallization. Let's keep going. Let's keep going, let's keep going, let's keep going. So a fluorescent substance, when exposed to the atmosphere, they lose water of crystallization. Now the last one, effervescent substance. Effervescent substances are substances that produces gas bubbles when dissolved in water. They produce gas bubbles when dissolved in water. Effervescent substances are substances that produce gas bubbles. Gas bubbles. Produce gas bubbles when dissolved in water. Gas bubbles. Gas bubbles. Example, we have sodium bicarbonate. Na2CO3. Just call it sodium carbonate. When you dissolve Na2CO3 in water, it will release CO2 gas. CO2 gas bubbles. Citric acid. Citric acid is also what? Effervescent. Citric acid is also what? Effervescent. They release gas bubbles when dissolved in water. Class, we digress a bit, but it's for a great course. All these things are important for Jamb. Don't forget, we are still on that separation technique, but look at a lot of things we have learned today. If you notice, this class is very rich. I've dropped a lot of things. Anhydrous, hydrated. We have talked about hygroscopic deliquescent. Let us keep going, let us keep going, let us keep going. Let us keep going, let us keep going, let us keep going. This is a detailed chemistry class. If you are still there, say, sir, I am still here. I'm not going anywhere. If you are still there, say, sir, I am still here. If you are still there, say, sir, I am still here. I am still here. If you are still there, say, sir, I am still here. I am here. We are not going anywhere. So we're looking at crystallization. Remember, you said you will stay to the end. You will stay to the end. Crystallization. Crystallization. So I was explaining crystallization, and that's what brought me to all those things I taught you just now. We say it's used to separate salt. Check your notes. We wrote down that crystallization is used to separate salts, which decompose easily on eating from their solution. And we say in crystallization, the salt solution is first heated to evaporate some of the solvent. The solution then becomes saturated. Check your note, go back to crystallization, you see it. The solution then becomes saturated. Now, when the saturated solution is cooled, continue writing. When the saturated solution is cooled, when the saturated solution is cooled, when the saturated solution is what? Cooled. When the saturated solution is cooled, crystals of the solute begins to form. When the saturated solution is cooled, crystals of the solute begins to form. Crystals of the solute. Crystals of the solute begins to form. When the saturated solution is cooled, crystals of the solute begins to form. When the saturated solution is cooled, crystals of the solute begins to form. Yes. Note, they can ask you in the exam, which separation technique is used in purification of seawater? Note, crystallization is used in the purification of seawater. Crystallization is used in the purification of sea water. And is mostly employed when the purity of the product is important. What separation technique is mostly employed when the purity of the product is important is crystallization. It is mostly employed, note, this example, note is a main example. It is mostly employed when the purity of the product is important. When the purity of the product is important, we use crystallization. Class, let me simplify the crystallization very well for you. Let me simplify it very well for you. Are you aware that if you have a solution that contains 3 salts, follow me. Salt A, salt B, and salt C. A solution contains 3 salts, salt A, salt B, and salt C. What you just wrote down now is notes, but let me help you understand. What you just wrote down now is theory, English. But let me help you understand the practicality of what happens in crystallization. Let us say a solution contains 3 salts, salt A, salt B, and salt C. Are you aware that every salt has a temperature at which it dissolves? Every salt has a temperature at which it dissolves. Anything below that temperature, the salt will no longer dissolve. Class, let us say we have A, B, and C. A dissolves at 50 degrees Celsius and above. Anything from 50 and above, A will dissolve. Anything from 60 degrees Celsius and above, B will dissolve. Anything from 70 degrees Celsius and above, C will dissolve. So 50 and above, A will dissolve. 60 and above, B will dissolve. 70 and above, C will dissolve. But anything below 50, A will not dissolve in the solution again. Anything below 60, B will not dissolve. Anything below 70, C will not dissolve. Now, what does it mean for a salt to no longer dissolve? Class, that salt you used to put in water in your kitchen, that salt in your kitchen, your NaCl, your table salt that you put inside water. Are you aware that salt can decide not to dissolve? That salt can decide not to dissolve. Anytime a salt say it no longer wants to dissolve, what happens is precipitation. What is going on currently is precipitation of the salt. The salt will now come out as a crystal. The salt will come out as a what? Crystal. It's possible. Anytime the temperature is not right, class, every salt dissolves at a particular temperature. If the temperature falls below that temperature, it will not dissolve. It will come out of the solution as crystals. So let us say we have salt A, B, and C. And this total solution is at 100 degrees Celsius. Class, at 100 degrees Celsius, everybody here will dissolve because 100 is greater than 50, greater than 60, greater than 70. Remember we told you, A will dissolve at 50 and above. 100 is bigger than 50. B will dissolve at 60 and above. 100 is bigger than 60. C will dissolve at 70 and above. 100 is bigger than 70. But anything below 50, A will start coming out as crystal. So class, if you want to bring out A from this solution, what do you need to do? Start reducing the temperature of the solution. Reduce the temperature. How do you reduce the temperature? Start cooling it. Class, increase in temperature is called heating. When you increase the temperature, it's called heating. When you reduce temperature, it's called cooling. When you start bringing down the temperature 100, 80, 70, as soon as it gets to 69, below 70, who will come out first? Tell me. C. Because below 70 is C. Class, you start seeing crystals start coming out of the salt. Crystals. Anything that's coming out at this point, you know it's C that is coming out because you already know the temperature of C. You collect C crystals, collect it. After collecting C, once you get to 60 and it drops below 60, any crystal that's coming out is B. And once you drop to 50 and below 50, 49, A crystals start coming out. And this is how the process of crystallization takes place. You collect the crystals of the salt out of the solution. I hope this is better. Let us move forward. Let us move forward. The next separation technique we'll look at is decantation. Decantation. I hope you are still there. Decantation. 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 I hope you are still there. Right now, decantation is the pouring away of a liquid from solid impurities. Decantation is pouring away of a liquid from solid impurities. Decantation is pouring away of a liquid from solid impurities. Decantation is pouring away of a liquid from solid impurities. Class, decantation, to decant means to pour. Some of you do it when you maybe, I don't know if you have ever soaked garri before. If you have soaked garri before, you want to remove some impurities, you just pour some parts of it, right? What you are doing there is chemistry, decantation. You are decanting. What is going on there is decantation. You are decanting. You are decanting. What is going on there is decantation. You are decanting. That one is very simple. Let's go to centrifugation, class. Right hand, centrifugation. Don't forget we are covering all separation techniques. Centrifugation. 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 This is a technique used, centrifugation. Let me spell. Centrifugation. This is a technique used for separation of particles from a solution. This is a technique used for separation of particles. This is a technique used for separation of particles from a solution according to their size, shape, density, viscosity of the medium, and speed. I'll come again. This is a technique used for separation of particles from a solution according to their size, shape, density. According to their size, shape, density. Viscosity of the medium. And speed of flow. Speed of flow. And speed of flow. Note, in centrifugation, the particles are suspended in a liquid medium and placed in a centrifuge tube. Note, in centrifugation, the particles are suspended in a liquid medium. In centrifugation, the particles are suspended in a liquid medium. In centrifugation, the particles are suspended in a liquid medium. And placed in a centrifuge tube. And placed in a centrifuge tube. The tube is then placed make sure you are writing. Is then placed in a rotor and spinned. And what? Spinned. The tube is then placed in a rotor and spinned at a definite speed. The tube is then placed in a rotor and spinned at a definite speed. And spin at a definite speed. So it spins. The rotor spins the tube. It spins the tube. What does the spinning cause? Write down. The spinning causes the solid particles in the suspension to be thrown to the bottom of the test tube. Class, the heavier particles now go to the bottom, while the lighter particles remain on top. You can then easily separate them by decantation. The spinning causes the heavier particles in the suspension to be thrown to the bottom. The spinning causes the heavier particles in the suspension to be thrown to the bottom. The spinning causes the heavier particles in the suspension to be thrown to the bottom. While the liquid part remains at the top. While the liquid part remains at the top. Class, those are the key separation technique. One more separation technique we'll look at before we round up separation technique is chromatography. Please write down chromatography. 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 Class, there's a high chance for a question to be asked on separation technique. You know the funny thing about Jamb, preparing for Jamb exam, is a gamble. You know, all this separation technique we are learning now, it might just be one question that will come out. Well, lecture is setting 40 questions, so they will not send 10 questions from separation technique. It's not possible. It might just be one question, but that one question, if you don't know where it will come from. That's why you must know everything. Are we together? Chromatography is a method used for separating a mixture. Chromatography is a method used for separating a mixture by taking advantage of their different rates of movements. Chromatography is a method used for separating a mixture by taking advantage of their different rates of movement. Chromatography is a method used for separating mixture by taking advantage of their different rates of movement in a solvent over an absorbent medium. Chromatography is a method used for separating a mixture by taking advantage of their different rate of movement in a solvent over an absorbent medium. Over an absorbent medium. Over an absorbent medium. Chromatography is a method used for separating what? A mixture by taking advantage of their different rate of movement in a solvent over an absorbent medium. Over an absorbent medium. Over an absorbent. Hope you are still there. Hope you are still there. Hope you are still there. If you are still here, say, sir, I am still here. I have not left. Sir, I have not left. Sir, I have not left. Sir, I have not left since the beginning of this class. Sir, I am serious. I think I'm joking, sir. Sir, I have not left. I want to pass my Jamb this year. If you have not left, say, I have not left. Chromatography is a means of separation that is used to separate dyes in colored ink. It's a means of separation that is used to separate dyes in colored ink. Used to separate dyes in colored ink. is used to analyze component of blood or urine. Used to analyze the components of blood or urine, class. In the medical field is used. If you ask you in the exam, what method of separation is used to analyze the components of blood or urine? Which of the following separation technique will likely be used? Or which of the following technique will you recommend to test for the components of blood or urine? Chromatography. Chromatography. Don't forget, every Friday in the Jamb Master class we have mock exam. See, your Jamb day, I'm committed to you. Every Friday you write exam. You cannot escape it. Every Friday you write exam. This last week Friday we wrote mathematics, we wrote biology, we wrote chemistry, we wrote physics. Our English teacher even did English test. We did English exam. Every Friday you will be tested to your Jamb. Let me see how you will not get to it. Very soon we'll start our Jamb online camp. You will delete your TikTok, delete everything. We must pass Jamb this year. It can also be used to identify the components of petroleum. What separation technique can be used to identify the components of petroleum is chromatography. Chromatography can also be used to identify the components of petroleum. Chromatography. In case you don't have our timetable, now you are watching me live, take our timetable. Today is Sunday. Sunday we do chemistry. Monday, what do we do on Monday? Monday we do English. Monday we do English. What do we do on Tuesdays? Tuesdays I teach physics. Tuesday is physics. What of Wednesday? Wednesday is biology. This is the Jamb Master timetable. What happens on Thursday? Thursday is maths. What happens on Friday? Friday is mock exam. Friday is what? Mock exam. Friday is mock exam. Friday is mock. What happens on Saturday? Saturday we do English again. English is one that takes the highest score in Jamb, you know. All other subjects are 40 questions. English is 60 questions. So if you score high in English, you have already boosted your Jamb. Then now master in chemistry and physics, you blasted it. Then you either do biology or maths, add something to it. You have finished your Jamb already. You have finished it. If you do very well in English, then you taught physics and chemistry very well. You blast them very well. Then even if your biology and math is, people that score 300, there's always one course they did not do so well, but the other three they held it very tight. They blasted it. Nobody will get 400 over 400 in Jamb. Nobody will get 400 over 400. If you want to get 300, it means you can still miss 100 marks and get 300. And 300 will land you any course. If you hold your physics strong, hold your chemistry strong, your English something that can easily pass your English. Then you know you're doing maths or biology. Add it, anything that can come in from there. You blast your Jamb. You blast your Jamb. Now, these are the different uses of chromatography. Dyes in colored ink, test for blood or urine, components of petroleum. What are types of chromatography? You could be asked in the exam. Which of the following is not a type of chromatography? What are the types of chromatography? Let's go. We have 5 types of chromatography. We have paper chromatography, paper. 2, we have column chromatography, column. 3, we have thin layer chromatography, thin layer. Thin layer. 4, we have gas. 5, we have ion exchange chromatography. Five types of chromatography we have. 5 types of chromatography we have. You want to join our class? Message me. This is my WhatsApp number. I like your class, sir. Let me join your private class. Because you will not be able to access any of these classes if you are not registered with, if you have not paid for my class. You will not access all this mock exam. Everything here is paid. If you are probably watching this video because I allowed you to watch it, I'm just giving you a chance to join our class. Very soon you will stop seeing my link. I will stop sharing link to anybody. I will only deal with my students. So you still have the chance to join us. This is our timetable. It's a serious class. You should that we coach you from Sunday to Saturday. What's the time for each day? 8 p.m. 8 p.m. Every day 8 p.m. Every day 8 p.m. Every day 8 p.m. Every day 8 p.m. Ladies and gentlemen, we are now done with separation technique. Congratulations. 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 If you are still here, say, sir, I am still here. If you are still here, say, sir, I am still here. If you are still here, say, sir, I am still here. Before we go any further, I must remind you that matter can exist in 3 states. Remember, matter can either be a solid, liquid, or gas. Solid, liquid, or gas. Class, when the substance moves from solid to liquid, it has a name. When the substance moves from liquid to gas, it has a name. When it moves from solid to gas without passing through liquid, it has a name. When gas also comes to solid, it has a name, which I've told you today, right? When gas goes to liquid, it also has a name. When liquid comes to solid, it has a name. Let us learn the name quickly. So solid to liquid is melting. Is what? Melting. Liquid to solid is freezing. It's called freezing. Solid to gas is sublimation. Gas to solid is deposition. Liquid to gas is vaporization. Also called boiling. When something is boiled, it has vaporized. You can call it vaporization, you can call it boiling, you can call it evaporation. All these names work. Boiling, vaporization, evaporation. All these names work. Gas to liquid is condensation. Write down these names. Condensation. Gas to liquid is condensation. Gas to liquid is condensation. Class. In our next class, our next topic, the next Jamb Master Chemistry class, next topic, we're going to be looking at the particulate nature of matter. The particulate nature of matter. Our next topic, the particulate nature of matter. I don't want this video to be too long, so I'm going to stop here. But there will be another video on our next topic, the particulate nature of matter, where I'll be teaching you everything about matter, balancing of chemical equation, reactions, stoichiometry. Some of your issue is balancing of equation. I'll teach it. I'll teach you all the methods, how to use algebra. You know, they can use algebra to balance equation. I'll teach you how to use algebraic method to balance chemical equation, so you can blast your Jamb. Are we together? I'll teach you about empirical formula, molecular formula, percentage composition, isotopy. We're going to be breaking it down. Limiting reagent, how to determine limiting reagent and excess reagent of a reaction. Are we together? Mass to mass stoichiometry, mass to volume stoichiometry, mole to mole stoichiometry. We're going to be breaking down chemistry. Are we together? Dilution formula. There's what we call dilution formula. Concentration of solution. We're going to look at concentration of solution, so that this Jamb will be your last Jamb. Please, if you are not registered with us, message me now. Send me a WhatsApp message so you don't miss out. Send me a WhatsApp message. This is our class timetable. It's a very serious class, you can see. If you're watching me from YouTube, you're watching me from TikTok, you're watching me from anywhere. Sir, I want to join your class. You are only watching this video because you are lucky you're able to see it. There are many other videos on my channel that are locked that you won't be able to see until you have registered with us. So I want to be part of your group. We have a private WhatsApp group I'm going to add you. So you can join our private class and be writing our mock test every Friday from now to Jamb. If you write this mock test from now to Jamb, you will blast your Jamb. You will blast your Jamb. I'm the one saying it. If you stay to the end of this class, say, sir, I stayed to the end. Let me see in the comment section. Sir, I stayed to the end. 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 This is 145 minutes of serious coaching. The only reason why I'm stopping here because I don't want the video to be too long. You know, it's not how far, it is how well. It is not by how far, it is how well. There's a way I want this next topic to be on a fresh brain when you are relaxed again. I want to get it. I don't want to rush it. I want you to learn this next topic because it's balancing of equation. I can't teach you now that your brain is already full with other things. I want to start this topic on the first fresh day. Are we together? Well, I'll teach you everything about matter, but that is atomic theory, the multiplication of that is atomic theory. You know what we call the non-stoichiometric species. I'm going to be breaking down Jamb. I'm going to be breaking down chemistry. You want to join the Jamb master class? This might be the last video you see of us if you have not yet registered with us. If you are not on my private class WhatsApp group, this might be the last video you see of us. You might not be able to write a mock exam. Message me now on WhatsApp. Let me add you. Sir, let me join. How much? I will pay. I will find a way. These people that are joining, they have money more than me. Some of them don't have money, but they found a way. I will find a way, sir. Message me on WhatsApp now and join us. Alright, ladies and gentlemen, good night. Do have a nice night. Tomorrow we have English in our Jamb class, 8 p.m. Have a good night. Make sure you read, make sure you study. Prepare for our mock exam on Friday. We have the mock exam on Friday. Start reading ahead this week. I will drop 2 topics in biology that you read this week. My private students, every week I drop 2 topics for them to read. I will drop 2 topics you're going to read in biology for this week. See you tomorrow for English class. You want to be our member? Message me now. Look at the WhatsApp number. Message me now. Good night, everybody. Good night, everybody. Good night, everybody. You have a friend that's writing Jamb, direct them to us. You have a friend, a cousin, a brother, direct them to us. Say, come and join my class. This man is teaching us very well. Come and join my class. Come, let me give them my number. Give them my number, sir. Come and join this man class. You will pass your Jamb. Don't pass alone. Don't pass alone. All right. Good night, everybody. Good night, everybody.